Okay, so the worksheet has a couple of problems, two types of problems that you don't see in the textbook that I'm pretty sure will be on the final because they're in the practice final. So one of them is finding out, well, they're money problems, finding out how many of each kind of coin you have if you have the total and you know how many are there. So I'm going to walk you through one or two and then you can try the rest on the worksheet. So in this problem, Nick has an equal number of pennies. Let me highlight some stuff here. That part's important. Pennies, nickels, and dimes, and it totals 368. How many of each does he have? So they want you to figure out how to build an equation to this. First thing you want to do is name your variable. So let's just call C the number of coins. The reason I'm not using like an N for nickel, a P for penny, a D for dimes is you won't be able to solve an equation that has multiple variables in it. So we want an equation that has one variable consistent all the way through. So we can look at the relationship between pennies and nickels and dimes. And since they're all equal, I can just say C is the number of coins. So if I know I have 2 dimes, I know it's going to be 10 cents times 2. If I know I have 5 dimes, it's going to be 10 cents times 5. So if you think about adding up your pennies plus your nickels plus your dimes you know that is supposed to equal 368. But again, you can't have 3 variables. So let's talk about pennies. If you know how many pennies he has, and you know each of them are worth 1 cent, so you can go 0.01 times C, the number of pennies. Because C is going to be consistent throughout all of them because they said there was an equal number. Okay, so then I want to look at my nickels, and I know my nickels are worth 5 cents, so that's going to be 5 cents times however many coins I have. And then the dimes are going to be 10 cents, so 10 cents times the coins. It equals 368. Whoops, decimal in there. So at that point, you have one variable going through the whole equation, and so then you can just combine your like terms and solve your problem. So I can add 0.01C plus 0.05C plus 0.10C. Because they're all C's, I can combine them, and they make 0.16C, and that's supposed to equal $3.68. So I can divide by 0.16, and I get C equals 23. So that must mean there's 23 of each type of coin. I could go and test that out. If I have 23 pennies, that's going to be 23 times 0.01. If I have 23 dimes, or nickels, sorry, that's going to be 23 times 0.05. And if I have 23 dimes, that's going to be 23 times 0.10. And then I can add these up and see, do they really equal the 368 they're supposed to? And they do. So then I know that I have it correct. Okay. Make sure that when they ask a question, that you're going back and you're making sure that you have the answer to it. How many of each? So 23 would be the answer for all 3. Let me show you one where they're not all equal. Okay, so in this problem, a coin collector has 35 coins. That's important. And they're nickels, dimes, and pennies. And the value is $2.55. And the rest of the problem is there are twice as many dimes as nickels and half as many pennies as nickels. And so this becomes important as we build it. So let's just take a look at what we have, and then we'll try to make an equation with one variable. Okay, so we have nickels. And since all of these are referring to nickels, I'm going to go ahead and mark my variable for nickels as n. We're going to have different amounts of each, so I just can't say C is the number of coins. I can't do it this time because they're different. Okay, but I know I have nickels, and then I have dimes, but I don't want to call dimes D. But if I look up here, there are twice as many dimes as nickels. So I can call dimes 2 times n. Because I know if I call nickels n, and there's twice as many dimes, I can multiply it by 2. And then pennies, I know there's half as many pennies as nickels. So 1/2 times the nickels. Now with this, I can build an equation because I only have one variable. But when I build my equation, I've got to think about the cost, how much each of them are. And so a nickel is 5 cents. So I'm going to have 5 cents times the number of nickels, which I called n, plus, and now I'm going to look at the dimes. I have twice as many dimes, but dimes are 10 cents. So I'm going to write 10 cents times 2n, which stands for how many dimes there are, plus half as many pennies, and pennies are 1 cent, and I'm going to multiply that by 1/2 n. And I'm running out of room. I'm going to write this on the next screen because I need to write that it equals 255. Whoops, this was 225. Sorry about that. 225. Okay, so 225. There we go. Okay, so now I can solve my equation. I can multiply and add all of these. I can combine all of my n's, and you should get 0.255n equals 2.25. No, that was a 5. Oh, I can't even read my own writing. Change this back to a 5. Otherwise we're going to have not whole numbers. There we go. Sorry about that. I'll go back and change that to 225. To 255. What did I just do? There we go. Okay, so now I can divide by 0.255, divide by 0.255, and I get n equals 10. So that means that I have 10 nickels. So they asked me how much of each I have. Well, if you remember, n equaled the nickels. So I have 10 of those. 2n equaled the dimes. So if n is 10, then 2n is 20. And all I did right there is I put a 10 right there. 2 times 10. And then I said I had half as many pennies, so 1/2 n equaled the pennies. And again, if n is 10, then that makes that 5. If I add all these up, I want to make sure that those add up to the 35 coins, and then also that if I multiply them all, they add back up to the 255. So those are the type of coin problems you'll have. There's a couple on the worksheet, and then I'm going to try and put one in the next quiz so you can have a little bit more practice because they do have those on the final. The other type of problems they had that I noticed they had in the final, and we had them on the worksheet, they were interest rate ones, so I want to go through a couple of those first. So here's how the interest problems go. First thing, you should know this from the previous math class, but simple interest, if you want to find out how much interest you're going to get, you take your principal. Principal is just the money you're putting in. You multiply it times the rate times the time in years. And so that they assume you already know. Okay, so if you take a look at this, they're saying they're taking this $6,000 and they're putting it into two different accounts. One account gives you 3.4% interest, one gives you 2% interest. But in the end, you make 148. So if you build an equation, if you say, I know that the 148 has to equal like the account number 1 plus the account number 2, how much you make off of it. And so if interest equals P equals R times T, how much do you put into account number 1? You don't know, so you say N. But you do know you're going to get 2% on that first account. So you're going to multiply it by 0.02, because a percent written in a decimal is dividing it by 100. And then it's 1 year, so you can multiply it by 1, or you can just drop off the 1. So this is principal times rate times time. Okay. So then the second account, you don't know how much goes in there either, but you can't call it another variable. But you do know that whatever went into that account is $6,000, take away whatever went into the first account. So that's how you can get away with having just one variable. And you know this account has an interest rate of 3.4, which in a decimal is 0.034. And you know it's for 1 year. Okay, you know that all has to equal $148. Once you've done a few of these, they become pretty simple because they're all kind of the same thing. You have one account and you name it, and then the other one is always the total minus that. Okay, so now you're going to have to solve this. So n times 0.02 times 1 is 0.02n, plus, over here you're going to have to use some distributive property, because you have that quantity with the subtraction in it. So let's see. So 6,000 times 0.034 is 204. And then 0.034 times n is 0.034n. And then times 1 is not going to matter. So at this point this all equals 148. So I'm going to combine my like terms. I've got 0.2n and I've got a negative 0.034n. Together that makes negative 0.14n. I still have the plus 204, and I still have the 148, and I'm going to move to the other page. And I had the 204. So I'm going to subtract 204 from each side. And it's okay that I'm in the negative right now. It doesn't mean you lost money, just wait until the end. So over here I get a negative 56. But remember on this side I have a negative 0.014n. So I'm going to divide by negative 0.014, negative 0.014. That means I'm going to get a positive, and I get n equals 4,000. So that means that you have to answer the question. Okay, that means that $4,000 went into the account that we labeled n. So think back to what we called n. We called n that first account that we figured had 2% interest. And so to finalize your answer, you have to say how much went to which account. So 4,000 at 2%. Well, if there was 6,000 altogether, that means that the leftover 2,000 had to go into the account that was 3.4%. You could run this backwards and double check it. You could go 4,000 times 2% plus 2,000 times, what was it again, 3, 4? 3, 4. And you get 148, which is how much you made. So you know that's right. So there's a couple of money problems on there. If you go through the worksheet and you want me to work out any other types of problems, there were a couple that are perimeter problems. If you need them worked out or you want me to make a couple more for you to practice from, just let me know.